Hello friends, welcome to this new course on overview of free and open source software FOSS for geospatial. This is a 1 week course which starts today on April 24th and goes up till April 28th, 2023. Here we will have 5 lectures, uh, namely FOSS for desktop GIS, which will be taken today by myself, FOSS for spatial DBMS, which will be taken by Shri Oberoi tomorrow, FOSS for WebGIS, which will be taken by Shri K. Shivareddy on 26th, FOSS for 3D GIS by Shri Ashutosh Kumar Jha on 27th. On the final day, we will have a lecture on overview of geospatial technologies by Dr. Vandita Srivastava. I am happy to inform you that we had an overwhelming response to this course and over 6,400 candidates have applied to the course. You are among the lucky few of the 4,200 approved participants, and I am also happy to know that around 660 institutions are part of this program today. The approval was done on the eligibility criteria mentioned on our brochure, that is final year UG students, PG students, faculty, researchers, and staff of state and central institutes and organizations. So, with that brief overview, let us start with today's session on free and open source desktop GIS. My name is Prasun Kumar Gupta. I am with the Geoinformatics department here at IIRS Dehradun. We are a unit of the Indian Space Research Organization, and this entire course is based on free and open source software. It may be a new term for some of you, but knowingly or unknowingly, we are already using a lot of open source softwares. For example, some of you may be viewing this session on a web browser, and the web browser could be Firefox. Did you know that Firefox is an open source browser? Similarly, a lot of videos and audio that you play is using the VLC media player, which is also an open source software. A lot of you are in the academia and you probably are using some sort of learning management system based on a software called Moodle. This Moodle software is also an open source software. Similarly, there are many such examples like the R language used for statistics, the SSL secure network framework for secure web browsing, the Linux operating system, the Apache software for hosting websites, PHP, Python, and MySQL. These are programming languages, general purpose programming language, and database programming languages. These are all examples of very popular open source tools. So, what is open source and why do we need it? First thing is that open source means that these softwares are available to you for free. That is, you do not pay any money to use these softwares. Second, and a bigger advantage, is that the source code is available for these software. So for example, if you are writing a computer program and the end result, that is the executable, is the final software. So if you give this executable along with the source code, then you are allowing the users to have control over the software. They can change the software. That is what is open source all about. Since the source code is available, you have more control on the software. You can change bits and pieces of the software. You can add more things or remove things and customize the software according to your requirements. That also brings me to the third point, that is, it is a flexible software. You have the flexibility to change the software as and when required. Now, since these are not developed by a single company or a single developer, there are many volunteers who are developing this software. So you have more eyes, that is, more people working on it, more contributors. So the quality of the software is better as compared to its counterpart, which is also called the closed source software. And also, it has been seen that open source softwares are leading the innovation in the software domain. That is, most new functionalities that come appear in the open source softwares before, and then it comes later in the closed source softwares. So the obvious advantages of the open source softwares are that it decreases software costs, it increases security and stability, especially in regard to the malware. It protects the privacy of users and gives the users more control over their own hardware. The the abbreviation of free and open source software, which is FOSS or FOSS, may be misleading. Here, the term free does not specifically refer to price. Here, free refers to liberty, as in free speech and not free food. Here, for in open source softwares, the users or the people who use the software have the freedom to run the program for any purpose. You need not tell the software vendor or justify why you're using one software for any specific purpose. Second, and more important, is that you have the access to the code and you can study how it works and possibly change it. Many a times you have an algorithm on the software and you just click it without knowing what is happening in the background. In case of open source softwares, since you have the access to the source code, you have the freedom or you have access to study how it works and to change it. Third is that since you have the software and you have the permission, you are free to redistribute copies of the software. The software doesn't require any serial keys or any license or dongle, etc., to activate the software. The software is available free of cost and you can distribute it to your friends and to your colleagues without any worry. You can also redistribute copies of modified versions of the software. Now, let's say you got the source code and you modified it and you customized it and you made it suited for a specific purpose. You're also free to redistribute this new and modified version of the software so that other users can use it and employ it for their own specific purpose. These all freedoms are defined in the GNU philosophy, the link for which is given at the bottom of the slide. Again, let us look at the differences between what is open source software and what is free software, or also known as freeware. You may have come across terms like shareware or freeware. Basically means that some softwares which are given to you for free, but they do not give you the source code, which is quite not an open source software. So in case of open source software or OSS, users have the right to access and modify the source codes. That means the program in which the software is written, that program is also given to the users. This enables the users to have access to the original source code, study the source code, and modify it if required. Whereas in case of freewares or free softwares, these are usually distributed in form of binaries. That means it will be given to you as a setup file or a exe file for Windows users, free of charge, but it will not, the source code will not be given itself. Why is that a problem? Now, in such cases, you do not know what is happening in the background. You do not know how the software is working. So, for example, you are doing a remote sensing or a GIS or a digital image processing operation, and you give in some input, it gives some output, but you do not know how it happened. Many a times, these outputs are wrong. So, in case of open source softwares, since they are maintained by a community of volunteers worldwide, even if the original programmer or the developer has stopped working on the software, the later the users or the developers who have joined usually keep the software alive and they give support for the software. Usually, all open source softwares have a strong user and developer group that manage and maintain the software or the project. Many a times when you use the program or the software, you will come across some issues, and when you search on Google, you will find a lot of people on several platforms or groups, online groups, or communities or websites like Stack Exchange giving solutions for these softwares. So, open source softwares have a very strong user base and they are ready to help you in case of any kind of issues, may it be a very simple installation issue or a very advanced issue. Whereas that kind of benefit is not available with freewares. The developer of freewares could abandon the project at any time, and the final version then would be the last version of the software. Since you do not have access to the source code, you will not be able to make any enhancements or any further developments in the software. So, free softwares are different from open source softwares. Only when the source code is available can the software be truly called an open source software. This is a very interesting essay written by Eric Raymond called The Cathedral and the Bazaar: Musings on Linux and Open Source by an Accidental Revolutionary. Although the essay is pretty long, here is an extract from Wikipedia which tells about the contrast or the difference between two software development models. First one is called the cathedral model, in which the source code is available for each software release, but the code developed between releases is restricted to an exclusive group of software developers. That means only a specific group of people know how the code works and know how to improve the software or to change the software. Some examples are GNU Emacs and GCC, which is a very popular C compiler. On the contrary, the bazaar model is in which the code is developed over the internet in view of the public. So there's nothing hidden, and the whole world can see the code and modify the code at the same time. Raymond credits Linus Torvalds, the leader of the Linux kernel project, as the inventor of this process. Raymond also provides anecdotal account of his own implementation of this model for the Fetch Mail project. So we have two examples, the Linux kernel and the Fetch Mail project, which is of the bazaar model. The essay written by Raymond also says that given enough eyeballs, all bugs are shallow, which he terms as the Linus law. Basically means that when you have more number of contributors or more number of users, any kind of issue or any kind of error becomes easy to catch and fix. Since the source code is available for public testing and scrutiny, and experimentation, all forms of bugs will be discovered. Raymond claims that an inordinate amount of time and energy must be spent in hunting for bugs in the cathedral model, that is the first model discussed here, since the working version of the code is available only with a few developers. So you can see how a sort of a closed model or a closed development environment is very different from an open development environment, and how that brings benefit in terms of making the software better and removing the errors or bugs in the software. Now let's come to the open source solutions or softwares that we have in the field of geoinformatics. Today, the field of remote sensing and geoinformatics and satellite based navigation has improved leaps and bounds. We have new branches of computer science such as human computer interaction and artificial intelligence, sensor networks, etc., making inroads in RS and GIS. So it is very imperative that we have softwares which can support our stakeholders which work on different new areas. So we have many GIS or geospatial softwares and almost a mature software, of well doing, well documented, very stable software in all these different categories of geospatial software, namely desktop GIS, spatial extensions to database management systems, web GIS, and code libraries. In today's lecture, we will focus on geospatial softwares which are available in the desktop GIS domain. It is also important to understand why we are studying about this subject. It's obviously a very big economy. This is an extract from the Geospatial Industry Outlook and Readiness Index 2018. It estimates that the GIS industry is roughly about 300 billion US dollars, which is growing at an approximate rate of 15 to 20% cumulatively annually. If you look at this pie chart here on the right, if you look at the pie chart here on the right, you will see that around 75% of the area, or the 75% of the market share, belongs to software and software services. So out of the 300 billion US dollars, about 75%, which is more than I think $200 billion, it goes into software and providing software services. And that is why open source softwares are a very important thing in this domain. When we talk about open source, many people feel that such kind of softwares do not have any license. Well, that is not true. Most proprietary software or softwares which are made by certain companies, they are given without the source code, and some of it may be given for free for download, also known as sharewares. Free software, on the other hand, may come as public domain software with source code, softwares with lax permissive license, copylefted softwares, that is software under the GPL licensing, and all this comes under this rectangle here, all of them called open source software because they come with the source code. Now, there are many terms here, such as copy left, GPL, and lax permissive license, which I would like to talk about. GPL stands for General Public License. You can read about more about all these on the GNU page and about the licensing philosophies. Now, let us go to the next slide, and this will help you relate to GPL and lax permissive and restrictive licenses and all that. So this is a table taken from a very popular paper written in 2009, way back in 2009, by Steinger and Buscher on an overview of current free and open source GIS desktop environments. This was published in IJGIS, and this is a very popular paper. This table tells about two main licensing things, licensing policies called GPL and LGPL, that is General Public License and Lesser General Public License. What does these two mean? You see, there are many open source softwares out there today, and all of them are released under different licensing terms. We will talk about how these licensing terms are formulated, but most of them are subcategories of these two general categorization called GPL and LGPL. What is the difference between GPL and LGPL? Softwares which are released under GPL cannot be mixed with other proprietary software. So there may be some softwares which say that, okay, I am giving this software for free to the world, and this is how it should remain. It should not be mixed with other proprietary software, and it should always, if you make any changes, it should still be released in the open source domain or license. Whereas certain developers feel that it will benefit the community and the research field, that if the software is released in a permissive license, in a lesser general public license, which allows the software to be mixed with other proprietary softwares. A very important example of this is a software called GDAL or Goodle, which stands for Geodata Abstraction Library, which is basically a library or a software library for reading and writing raster and vector files. It's a translator library, in fact, which converts one format to other. But since it is released under LGPL and it supports all known raster and vector file formats, it is used today by all softwares, may it be closed softwares or open softwares. So for example, even very popular softwares like Google Earth and ArcGIS and QGIS and any software, whether it be paid or free, they are all using this library called GDAL, which is released under the LGPL license. So coming back to the previous slide, open source softwares are released under different kind of licenses. Some licenses are little restrictive. They are also called copy lefted softwares because it is quite the opposite of copyrighted softwares. The copy left software philosophy says that you should have a software which should always be free. If you make any modifications, if you make any changes to the existing software, it should still be free in future. Whereas certain softwares are released under a permissive license like the LGPL license, which says that you can release the software or mix the software with other proprietary softwares. Also, software licensing is a big subject. It's a huge area and quite not our day-to-day requirement. Many a times we just need a software to do some certain tasks and we do not much care about the licensing terms. But if you're a software developer and if you've written some software which you are putting on GitHub or some website like that, where you want to give it to the community so that they can work, but you're not very sure on what licensing term to use, I would suggest that you go to a website called choosealicense.com. You can specify things like, do you want to permit it for commercial use? Do you want to permit modifications or private use? Do you want it to be used on the network? Do you want any? Do you want the same license to be carried forward, or you want to allow changes to the licenses? And whether you are ready to take any liabilities for damages that may happen or provide any warranties. So if you select such options, you will, if you select certain options like this, so if I have allowed these and not allowed these, it will tell you which is the correct licensing, uh, which is the correct license under which you should release the software. So when I tried something such as giving these permissions and giving these limitations, it said that your software must be released under AGPL version 3. Similarly, if you want a simple or a permissive license, you can select MIT. If you want to work with the community, you can select a certain license. If you care about sharing the improvements, if somebody has made the improvements to a software and he must share it with the community, you must release it with GPL v3. And there are many examples of software such as GIMP, Bash. Bash is a very common terminal that you use in, or shell which you use in Linux. Ansible, Rails, .NET, Babel. These are different softwares released under different licensing terms, uh, which you can also explore. Now let us come to actual individual softwares in the FOSS for G, that is free and open source for GIS or geoinformatics domain. QGIS, which is a very popular software uh, in this domain, is very popular, and it is evident from this graph that you see, uh, which is taken from Google Trends, which basically uh, accumulates all the data of people searching about these softwares. So you see, worldwide in the past 5 years, more number of, out of let's say 100 searches, 75% of the people are searching for QGIS, which is shown in the blue graph here, and only about 25% are searching for the software ArcMap, which is a very popular proprietary equivalent of the same. Not only QGIS, there are many open source GIS softwares which are available as substitutes for popular uh, proprietary softwares released by a popular company called ESRI in this domain. So, for example, if you just need a software for viewing remote sensing or GIS data, the proprietary software is ArcReader, and there are many open source equivalents available like UDig, GRASS, GVSIG, QGIS, and Awesome. Similarly, if you want to make maps and you want to use it for cartography, you can use ArcMap or ArcGIS if you have the money and if you have to use proprietary. Otherwise, there are free software like, again, UDig, GRASS, GVSIG, QGIS, and Awesome, which can help you make very beautiful maps. And I'll be showing you some of the examples using QGIS. If you want to do analysis with data, ArcReader may not be enough. You may need ArcInfo. And again, GRASS, Awesome, and plugins to QGIS or standalone Sextante can also be used. If you want to collect data from the field, there are many softwares in the open source domain available. Here, there's just one example of GVSIG mobile, but the other softwares like Q Field and Q Real Time and uh, a GeoODK. There are many softwares available today which help you collect data from the field uh, without the need of a paid software. Again, if you want to store, you have large amounts of data and you are concerned about concurrency and transactional integrity and things that you do in a multi-user environment. There are many people trying to access the same data, trying to change it, and yet you want to make sure the integrity of the data. You will have to use some sort of database, and generally people go for a paid service for this. But let me tell you, the free or open source equivalent, which is PostGIS, is very popular, very stable, and it supports petabytes of data and helps you serve efficiently to hundreds or thousands of users concurrently. Similarly, if you want to display the data that you have in a database or in files on the web, if you have data, we will talk about, I think Mr. Shiva Reddy will talk about more about the open source softwares which are available in the web GIS domain, such as Map Server, GeoServer, Degree, Open Layers, Leaflet. There are so many. They are very good equivalents to paid softwares like ArcIMS. Similarly, if you are looking for something like a spatial server, uh, uh, serving spatial data, you can use GeoServer, you can use Grass, you can use Extante. And if you're doing scripting, you're writing your own programs, you're writing your own tools, you're writing your own software to do the advanced or new algorithms, uh, you don't need to rely on, again, paid software. Free programming languages like PHP, Perl, Python, C Sharp, they are all available freely to you. So, to summarize, there are many open source geospatial tools available today. In the desktop GIS environment, there's QGIS, which is very popular, Jump, Ilvis, Mudig, GVSIG, Cosmos Saga. These are also some other important softwares. If you are more interested in data management and advanced analysis of the data, I'd suggest that you look at Grass GIS and Awesome. If you have large amounts of data and you are interested in doing spatial analysis on database management system, you will need to look at MySQL or PostGIS. If you are doing programming or scripting or command line or things in the text-based environment, you will need to know libraries or tools such as JDAL, OGR, GeoTools, Proj, and FDO. If you are looking for making web maps which are available on a browser without the need of any other GIS software, you will need to look at softwares like Degree, GeoServer, Map Server, MapBender, Open Layers, etc. For data visualization, if you have large amounts of data or specialized kinds of data, such as meteorological data or different other GIS data where you want to do certain algorithms such as clustering and all that, you may have to use Geoda, GeoVista, Grads. These are very popular softwares in these domains. And spatial cataloging, when you have large amounts of data, you generally need to catalog this data. You need to put them in a ordered manner, in a searchable manner, based on the metadata of the data. So for that, GeoNetwork is the most popular software in the world today. I have a small icon here called OSGeo Live. We will talk about more about this in the last few slides. Now, OSGeo is a global body which looks after many of these open source projects. It provides funding, it provides support, and it also has a page called OSGeo/resources, where you will find a lot of content on how to use this software. So here I can see a GIS at School guidebook for biology, geography, and science, introduction to GIS, tutorials with QGIS, general introduction to GIS, and many such tutorials available for users on this website. So if you are interested in learning these softwares and you want to, and if you're looking for good resources, I would suggest that you look at this website, osgeo.org/resources. Again, I'm talking about lot of these softwares in the open source domain. Which one will you use? So mostly I tell people that you should start with QGIS. Earlier it was known as Quantum GIS. But if you are already using some GIS software and you are acquainted with GIS terminology and GIS tools, I would suggest that you look at GRASS, which is also a free software, but it is slightly for intermediate to advanced users. And if you are if you are in the Java based platform, so in the next few slides I'll talk about why there are so many softwares and which one should you use. So for Java based users, you can use Jump, and then there is MuDig, which is also a popular software. There is another software called Saga, which is for a bit advanced users. So this slide just tells about, based on what kind of GIS, remote sensing GIS user you are, that software you should opt for. So for beginners, I would suggest QGIS. For intermediate to advanced users, I would suggest GRASS GIS. As I was telling you, there are a lot of softwares out there in the open source domain. And a lot of these softwares are primarily fueled by the choice of the programming language. So a lot of people who like to use C and C++ and .NET and all, they generally try to use the softwares given in this slide. But as an end user, if you are not a programmer, if you will not be playing around with the source code, but rather the end product itself, then this is not very important for you. But for those who want to go into the kernel and into the depths of the software and how it is working and why is it working the way it is working, you have to select the software based on your choice of programming language. So for example, QGIS, GRASS, Awesome, these are all primarily written in C++. Then softwares which help you do web-based mapping like Map Server, Map Guide, and database like PostGIS, and all these programming libraries, Proj, FD, OGMT, OGR, GDAL, GEOS, they are all C-based. And they are all very dependent to each other, or they all talk to each other. They are all interfaced with each other. So for example, as I told you, GDAL is used by all these software, PostGIS, Awesome, GRASS, Map Server, QGIS. QGIS also has a port for GRASS, it has a port for PostGIS, and also takes help of tools from GEOS and GDAL and Proj. So these entire software ecosystem, they are intricately linked with each other. And so many a times when you're using a single software, you're probably using tools from other softwares also. Similarly, there is a Java tribe of people who are more acquainted with using the Java programming language. In fact, the software JUMP actually stands for Java Unified Mapping Platform. So, in case you are if you know about the Java programming language and you eventually plan to go into actually modifying the software or improving the software, then I would suggest that you look at JUMP. A jump uses a library called GeoTools. GeoTools is and JTS, that is the Java Topology Suite. These are very important libraries which are used by mostly all of the Java based softwares such as GVSIG, Mudig, GeoServer, Jump, and Degree. So, uh, again, a very intricately mixed ecosystem in the Java programming language. In the .NET domain, Map Window is a very popular software. Whirlwind, Sharp Map, these are all uh, .NET based softwares. There are wrappers available to the JIDAL, OGR, and Proj 4 libraries, which helps users in other or developers in other programming languages also to use the same library. So, for example, JIDAL OGR is primarily written in C++ or C, but it has wrappers for Java, for PHP, for .NET, so that programmers in these different languages can also use the benefits of the JIDAL library. So, lastly, I would give you some screenshots of different popular softwares and what are the main advantages of using these software. So here you see a small image of the software called QGIS. QGIS looks like any popular GIS software. Here is the map panel. Here you have the list of layers, the browser panel, all your tools. There are icons and then the menu. And then there are very good things that you can do with QGIS. It's one of the most popular GIS softwares today. It's very user friendly, it's open source. It's primarily a GIS client. Why is it called a client? Because it can access data from any kind of GIS server. Here you can visualize spatial data, all kinds of satellite images, all kinds of raster and vector data, any kind of data that you collect from the field, any kind of data which is available on the web. So these web map services that can also be consumed inside QGIS. Any kind of data which is in a database. So you can connect to a database and then grab that data and view it here. Manage the data. You want to add certain things, remove certain things, edit the data, analyze the data, create new products from existing data sets. For example, you have a satellite image and you want to combine the bands to create certain indices like NDVI or other such indices. Or you have some vector data, you have some points, you want to do a buffer analysis, you want to do union of multiple layers. So all these kinds of analysis, you want to do network analysis, can be done on QGIS. And finally, compose beautiful printable maps. I will show you an example of some maps that we have published in high quality journal publications made on QGIS. So you can make these maps on any kind of GIS on the QGIS software and publish it on any kind of journal. It is very powerful, and thanks to the integration with Grass and Saga, these two softwares which are also very popular and they have more advanced tools, these have been incorporated or they have been sort of called inside QGIS. So once you install QGIS and you start it, you will also see functions from Grass, from Saga, and you can also integrate other softwares like R, the statistical language. And earlier you could also do things like TauDem and uh, Orfeo. These different toolboxes could also be integrated. But with recent upgradations and API changes, I think they are not currently integrated, but you can still do that in earlier versions of QGIS. It runs on all different operating systems. If you have a Linux based, if you have a MacBook, an Apple based, or a Windows based system, QGIS works seamlessly in all these operating systems, and it supports numerous raster vector database formats and functionalities. So, a very popular software. You can go to this website qgis.org, download it, and use it free of cost. There is no money required to download and use the software. The next software that I want to talk about is the Grass GIS software. Grass GIS provides powerful raster vector and geospatial processing engines. It has many advanced functionalities built in for raster data processing, vector data processing, and other geospatial processes in a single integrated software suite. In a single software, you can do all these different things. You can make maps, you can look at the attribute table, you can do different types of processes, save the outputs, so on. It includes tools for spatial modeling. A lot of these modeling that you do, predictive capabilities, those are all built in GRASS. Visualization of data, management and analysis of geospatial data, and processing of satellite and aerial images. A lot of these very niche algorithms, such as pre-processing satellite images, doing all your atmospheric corrections, all your geometric corrections, those algorithms are pre-built inside GRASS. So it's a very powerful software. It also comes with a temporal framework for advanced time series processing. A lot of you are probably doing things like change detection or multiple data, trying to find out what is the change in every pixel in the entire set of data. So that kind of time series processing is easily doable uh, using the GRASS GIS. And a Python API for rapid geospatial programming, both in QGIS and GRASS. In QGIS, it is called PyQGIS. In GRASS, it is called PyGrass. They have a separate library in Python programming language. So you can use all these algorithms in Python directly. So if you're a Python programmer, you can also use the good things in these softwares in your programs also. GrassGIS has been optimized for performance and large geospatial data analysis. So if you have large amounts of data which keeps your software crashing, then I think you should move over to Grass, which has been optimized for such kind of large data processing. This is the website grass.osgo.org for the Grass software. Another very popular software is called ILWIS, Integrated Land and Water Information System. This was very popular in the early 2000s. It was a PC based RS and GIS software. It is a PC based GIS and RS software, remote sensing software developed by a renowned institute called ITC in the Netherlands, that is Holland, and up to 3.3 version, that is in 2005, it was developed by the people or the scientists or faculty working at IITs. After that, they made it open sourced in 2007 and formed a separate organization called the 52 Degree North, and they were handed over the ILWIS development, and they are still doing it. A new version has been launched and with much more facilities. So it comprises of image processing, spatial analysis, digital mapping, and a comprehensive set of image processing tools, orthophoto processing, advanced modeling, and spatial data analysis and geostatistical analysis. So lot of these uh, things that you want to do in RSGIS softwares is available in this software called ILVIS. Again, this is the link for the software. For the .NET users, we saw map window is a very good option. It's Windows based open source GIS client. So if you probably foresee yourself using it on Linux, then map window may not be a good option for you. But if you're more acquainted with the .NET environment and framework, and you will be working on Windows, you can use the map windows software. It helps you do the same things: manage, visualize, edit, compose printable maps, has powerful functions based on integration with GIS and GDAL, and it is easy to incorporate with MS Office based products because it is the entire Microsoft ecosystem, such as if you have data in Excel or Access, all that can be easily integrated with uh, map windows. So we talked about GDAL a lot. It's a translator library. Comes with command line utilities to translate and process a wide range of raster vector geospatial data format. It is released under the very permissive XMIT open source license, and you can download it from jidal.org. PostGIS and GeoServer Map Bundle, these will be covered in detail by uh, uh, the next few speakers, so I'll not go over them. But there are softwares that you require for storing data in a database or for displaying data on a web and so on. Finally, as I told you, I will be talking about what is OSGeo Live. OSGeo Live is a mm, is an image that you burn on a DVD or on a pen drive, and then you can insert in your system and boot from the system. So it's a self-contained bootable DVD or USB thumb drive virtual machine based on Ubuntu, a version of Linux, which comes along with a lot of pre-installed geospatial software. Many a times people feel difficulty because they may have a earlier operating system, they may not have certain software patches and all that. So you don't have to install anything. You can download this file. It's roughly about 4 gigabytes, and then you download it and you burn it on a DVD or you burn it on a pen drive, and you put it in your system and reboot your system, and you will get an interface like this. And on the start menu, there's an option called Geospatial, where you have all types of GIS, open source GIS softwares like browsers, databases, desktop GIS, navigation and maps, spatial tools, web services, even sample data, and a lot of help available to you, everything on that single DVD. So it's very useful in a classroom kind of an environment where where it is difficult to install software on multiple PCs, but you can give them uh, a DVD or a bootable environment or a virtual environment where the softwares are all pre-installed. So these are just list of the different things that are already installed. So there are desktop GIS. So we talked about all these: QGIS, GRASS, GVSIG, MuDig, OpenJump, Saga. They are already pre-installed on OSGeo Live. Then you have browser-facing GIS like OpenLayers, Leaflet, Cesium, MapBender. Some of these will be talked about in the WebGIS lecture. Then you have different web services, You have different data stores like PostGIS, Rasterman. This is a very popular upcoming topic for multi-dimensional raster databases. And then for navigation, spatial tools, a lot of open source data like Natural Earth, OpenStreetMap, NetCDF, time series, precipitation, and temperature data. These are all coming in that DVD, some geospatial libraries and geospatial standards. I would like to wind up today's session by showing you some very interesting applications that have been built using QGIS. The first one is the visualization of buildings in Lower Manhattan, that is uh, in America in 3D. So I think I have the animation running already. So this here you see, I'll just pause the video. These are all building boundaries, and the height of the building has been shown in pseudo 3D. So basically, you're looking at it, looks like a 3D, and in a very nice interactive environment where you can rotate the images and you can rotate the environment and look at the area in detail. So you can see the taller buildings are shown in a deeper red color, and you can zoom in and zoom out. The next example that I want to show you is different travel time travel time by cars across West Sussex in Midhurst in UK. So here you see if a person is starting from this point and at the available speed limits and traffic congestion, what would be the uh, distance he would have traveled in, let's say, 11 minutes or 18 minutes and so on. So very useful for doing uh, urban studies where you want to find out where urban congestion or traffic congestion is there, where there is less congestion, where you need to focus some efforts and so on. So very interesting kind of network analysis based studies can be done using QGIS. The last example is actually from a published paper in ISPRS conference on how we have used OCM2, which is a sensor on board the OceanSat satellite of ISRO. And this data, we've taken the NDVI data and we've created a time series visualization over India. So you will see here, I have paused the video now, that the higher the NDVI, NDVI basically stands for normalized difference vegetation index. The higher the value means the more the greener the area, lesser the value, the more barren earth or no greenness or no vegetation in that area. So it is a multi-year animation and bi-monthly. So on 1st of and 15th of every month you will see one image, and the animation goes very quickly. So I'll just explain to you what is happening. So in the summer season you will see a lot of area which is red and orange, means there is no vegetation, only certain Indo-Gangetic belt and certain areas where water is available. You will see that there is higher NDVI, so means cropping is taking place. And as soon as the rain starts, that is in August, September, large parts of the country become green. That means, so all these white areas, I have masked out the forest areas and the urban areas and large water bodies. So we are only focusing on the areas where cropping takes place. So you'll see JJAS, that is June, July, August, September, a lot of cropping has happened. In the winters, only the northern belts. In January, this central regions have crops. Large parts of South India have no crops or very less crops. And as you go into mid-summers, April and May, the entire country again goes into orange and red, and then again back in June and July, the same process repeats over year and year. This kind of data, this kind of analysis can be done to find out cropping patterns. A lot of literature is coming on uh, in crop intensification, more farmers growing more number of crops. What is the irrigation availability? What is the water availability? What kind of soil condition is there? What kind of yield is taking place? So lot of such studies can be done using free data and free software. So finally, you can obviously make very beautiful maps using desktop GIS. This is a map of the Indian state of Uttar Pradesh. You can have inset maps, grids, north arrows, legends, multiple types of fonts, multiple types of lines and shadows, and so many different things. And all these data, all these maps are publishable. This is a paper that we published in International Journal of Remote Sensing, which is a high impact factor journal. And many such maps have been made and published by people on high quality journals. So that is the end of the slides that I have today.